Hello everyone, today we're going to be working on example 2.6 and it's asking us to determine the magnitude and direction of the resultant force. So the first thing that we're going to do is we're going to take each of these three forces that were given to us and we're going to try to find the horizontal and vertical components of each of those vectors. So we're going to take these three and we're going to find its vertical and horizontal components of each of them. So we're going to start off with f of 1. So we're going to try to find first its horizontal components. So f of 1 of x, so the first step, f of 1 of x. As you can see for f of 1, we were given this angle right here. So if we were to draw a triangle right here, we know that we're trying to find this side of the triangle, and we were given this side of the triangle. So we're trying to find the adjacent side of this corresponding angle. So we're trying to find the adjacent side to it, and we know the hypotenuse side to it. So by knowing that, we know that we could use cosine since cosine is adjacent over hypotenuse. So we're gonna do the 700 pounds times cosine of 30. And we're gonna input that into our calculator, and we wanna make sure that our calculator is in degrees. And that should give us a total of 606.217. And if we round that, that should be 606.22 pounds. So now we're going to move on to f of 2. So f of 2, and then we're going to try to find its x component. For f of 2, we could see that it is completely vertical. There is no x component or horizontal component to it. So we're just going to put 0 pounds. And then we could move on to f of 3. So f of 3 of x. So for f of 3, they give us that this is a 3, 4, 5 triangle. And we're trying to find its horizontal component right now. So we're trying to find the side of 3. And we were given the side of 5. So for this, we're going to do 600 pounds times 3 over 5. And that should give us 360 pounds. So like that, we were able to calculate the horizontal component of each vector. So now we have to calculate the vertical component of each vector. So to f of 1 of x. Oh, sorry. F of 1 of y, since we're trying to find vertical component now. So instead of using cosine, we're going to be using sine because now we're trying to find the opposite side of this corresponding angle. So now we want to find opposite and we know hypotenuse. So sine is opposite over hypotenuse, which is why we're going to be using sine instead of cosine this time. So 700 pounds times sine of 30. That should give us 350 pounds. Now for f of 2 of y. So f of 2, as we mentioned before, is already completely vertical. It is, there's just a y component to it. So for that one, we're just gonna write the 450 pounds. 400 pounds, sorry. And for f of 3 of y, we were given the 3, 4, 5 triangle. So this time we're trying to find the side of 4, and we were given the side of 5. So this time we're gonna do 600 pounds times 4 over 5. And that should give us 480 pounds. So now that we've found the horizontal and vertical component of each vector. We're gonna evaluate it to find the net horizontal and net vertical component. So what we're gonna do is we're gonna write out, we're gonna assume that going right is positive. So right positive. So f of r of x, since we're trying to find the net horizontal right now, is equal to, and there is, I skipped a step, sorry. So now we're going to go back to each of the horizontal and vertical components for each of the vectors. So here for f of 1 of x, we got 606.22 pounds, but now we have to figure out in which direction it's going. And as you can see, f of 1 is going to the left side. So for the f of 1 of x, that is 606.22 pounds going to the left. F of 2 of x, there's no force, so that's just 0. And then for f of 3, we could see that it is going to the right. So for that, for f of 3 of x, it's going to be 360 pounds going to the right. Now, as for our vertical components, f of 1 of y, we could see that our f of 1 is going down as compared to it going up. So that's why that's going to be 350 pounds going down, as well as our f of 2 and f of 3. They're also leaning or going down as compared to going up. So that's why the 400 pounds are also going to be going down, and the 480 pounds are also going down. So now that we have our signs for each of them, we said that we're going to assume that going right is positive. So this 606.22 pounds to the left means that it's negative. So we have negative 606.22. And then we have plus the 0 pounds. And then we have 360 pounds going to the right, meaning positive. So plus 360 pounds. And like that, we have negative 246.22 pounds going to the right, but we want to deal with positive numbers and not negative numbers, so we could just rewrite this as two, sorry, 246.22 pounds going to the left. Now we're going to assume that up is positive for the vertical component, so f of r is 5. So we have negative 350 pounds minus 400 pounds minus the 480 pounds. So we have a total of negative 1,230 pounds going down. But again, we want to deal with positive numbers and not negative numbers. So we have 1,230 pounds going, oh, sorry. For the first one, it's negative 1,230 pounds going up, but we want to deal with negative numbers, so we have 1,230 pounds going down. So now that we found our net horizontal and net vertical component, we can now sketch these components that we have to evaluate for our resultant force. So what we're going to do is we're going to draw out our x and y axis. So our y-axis, our x-axis, and we're going to take these two numbers that we found and we're going to sketch them all. So as for our x-axis, we have 246.22 pounds going to the left. That means from here we have 240. Let's make this a bit thicker. 246.22 pounds going zero. And as for our y component, we have 1,230 pounds going down. So that means we have 1,230 pounds going down in this direction. From there, we're going to try to evaluate for our resultant force, which will be somewhere around here. So to evaluate our resultant force, all we have to do is um, all we have to do is f of r is equal to the square root of these two forces. So 246.22 squared plus 1,230 pounds squared. And then we plug that into our calculator. 246.22 squared plus 1,230 squared. And that should give us a total of 1,254.4 pounds. And that is our magnitude for our resultant force. So this is our magnitude for our resultant force. This is the first answer, or the first answer to the first part of our example. So this has a magnitude of 1,254.4. Because here it asked us to find the magnitude of the resultant force. So the only thing that's missing is finding the direction of it. And we're going to find the direction of it we're going to find it going counterclockwise from the positive x-axis. So what we're trying to do is we're trying to find the angle starting from the positive x-axis, going counterclockwise until we hit this resulting force right here. And to do that, we're going to use things that were given to us, which we know that this side right here is the 246.22. 246.22. And we know that this side right here is the same as this side right here, which is the 1,230 pounds. And so we know that from the starting of the x-axis all the way over here, it's a full 180 degrees. So the only angle that we don't know is this angle right here. So what we're going to do is we're going to find that angle right there and add that to 180 to give us our full angle. So we're going to call this angle that we're trying to find theta. And to find theta, we know the opposite side of that angle and we know the adjacent side to that angle. So tangent is opposite over adjacent, which is why we're going to be using tangent theta to find our angle. So we're going to write out tangent theta is opposite over adjacent. So we're going to have our 1,230 pounds over 246.22. So theta is equal to the tangent inverse of 1,230 over 246.22 pounds. And we're going to put that into our calculator. Make sure your calculator is in degrees and not radians. And that should give you a total of 78.68 degrees, but we're not done there. We're trying to find the full angle. So we're going to call the full angle phi. So we know that phi is equal to the 180 degrees plus the 78.68 degrees. So if we add that to 180, we would get a total of 258.68 degrees. So this is our direction of our resultant force going counterclockwise from the positive x-axis, and this is the second part, or yeah, this the answer to the second part of the question. So once again, this question, this example was asking us to determine the magnitude of the resultant force, and we found out that the magnitude of the resultant force was 1,254.4 pounds, and then it asked us to find the direction also of the resultant force, and we found the direction of the resultant force counterclockwise from the positive x-axis to be 258.68 degrees.